In this problem, there are n squares arranged in a row from left to right, and m of those squares, square a1 all the way to square am, will be colored blue, whilst the rest will be colored white. We will be given a positive integer k just once and make a stamp of width k. And in one use of that stamp, we'll be able to color k consecutive squares to red. But the rule is we cannot color over a blue square. So what we're trying to find is the least number of uh, moves that we have to use the stamp such that there are no white squares left. So in the end, there'll only be blue and red squares. So what does this mean? If you look at the first test case, 5213, 5213, that means the number of squares 1, 2, 3, 4, 5, and then the color, oops, would be so 1 and 3 are going to be colored blue. So it'll be blue, white, white. So first we have to pick a stamp of size k. Let's assume the size of k is 1. Then in one move we can convert this white to red, white to red, white to red. So overall that will take us 3 moves. Then if k equals 2, then in one move we can convert this to red, red, but then we'll never be able to change this white to red because we'll either have to highlight white and blue, which we can't do because we can't put a stamp over a blue square, or this white and blue, which we can't do because again the stamp can't go over a blue square. So k equals 2 or larger cannot solve this question. So the answer has to be when k equals 1, and it will take us 3 moves. It will be 1, then 2, then 3. So that's the question. So first let's read in the input. Int n m vector int a m for m c n a I. So now we have read all the blue squares, and let's consider all consecutive sequences of white squares as a gap, right? So initially when this was white, this was white, this was white, we'd have 2 gaps. This is one gap, this is the other gap. And our goal is to fill up all gaps with this red paint, right? So, but to find gaps much easier. So let's say there were the 2 whites here. Then the best way to find a gap would be to add a extra blue square at position 0 and position n plus 1. So we can just look at every pair of consecutive blue squares, and from that we can find out the number of white squares between each blue square, and that means we can find out the size of every single gap, right? So let's do that. So now we also have to add an extra blue square at square 0 and square n plus 1. Now that we have that, let's sort everything. And let's create a vector called gaps. And for I between 1, a dot size. So if the size of the gap is not 0, we want to add the size of the gap to this gaps vector. And just a size of a gap would be 0 if there were 2 b's next to each other. So therefore there'd be no white squares between these 2 blue squares, therefore the size of the gap is 0. So to check if it's 0, we're going to say, so to find the size would be ai minus 1 minus 1. So as long as this is not 0, gaps dot push back that value. And like for example, if you look at these 2 blue squares at position 3 and position 5, they are consecutive blue squares. So the size of the gap here would be 5 minus 3 minus 1, which is 1, which is right because there's only one white square between them. Okay, so now that we've made this gap selector, we first have to check if it's empty. Because if all the squares we're given are blue, then we're done. We don't have to make a stamp at all. So if gaps, if gaps dot, yeah, dot size. So if gaps dot size is 0, then we just return 0. So yeah, we output 0 and then we return. Otherwise, we had to find the right value of k. And the right value of k is the size of the smallest gap, right? Because in this example that we had at the very start, uh, if k is 1, we can cover this one, and this one. But if k is 2, we can cover this first gap, but not this gap because it overlaps with the blue square. So the way to find the best gap is to find the smallest, the way to find the best value of k is to find the size of the smallest gap that isn't 0, right? And the case of 0, we took that into account over here. So what we can just say now is for each element in our gaps vector, k is going to be the minimum of itself. It's going to be the minimum, let's see, k, yeah, the minimum of itself and the element. And now we'll count the number of moves it will take. So for each element in gaps, answer plus equal, we want the upper bound, so it'll be element plus k minus 1 over k. Then see our answer. So the key thing here is we want the upper bound if we're given k. So in this case, let's say k equals 2 and we're given this kind of sequence, right? So we can do this in one move, so that's the size of the gap over k. But here we have 3, and 3 will take 2 moves. We can color these two first, so we can make this red, red, and then for this one we can repaint over a red square, so we can make this red, red. Oops. So overall, if there's a gap of 3 and k is 2, we'll need 2 moves. So it's just going to be the upper bound of the size of the gap over k. And that's exactly what we do over here. So now just to check. And voila.